And this brings us to the last thing we need to discuss before we jump on making some predictions about motion, is to understand the word deceleration. And this brings us to probably my least favorite word in the chapter. Deceleration, it's a word that we use in everyday life, everyday concept. However, almost the 0 times or only 99% of the time, we will not use this word in physics because it's confusing. And I'll tell you why it's confusing, but it's a concept, it's a word that we use in daily life. So let's take care of it and make sure we know, and so that after we learn physics, we know how to, we know why, and we can now tell people why it's confusing and stop using this word. All right, so what does it mean? So there's 2 ways to say it's equivalent. I'll give you both ways to define it. One way is it's the reduction of speed. Okay, it's the reduction of speed, and immediately, as you can tell, speed is the magnitude of velocity, and most of the time in physics we want to be precise. So when you talk about speed, it's less useful of a concept than velocity, because velocity includes speed. It tells you the speed and the direction, and you can be very precise, talk about the instantaneous velocity or the average velocity, right? You can talk about instantaneous speed, which is, for example, if you, let's say you drive 30 miles in 1 hour, all right? So if you're going to the grocery store, it's a very long way away. If you live in the middle of nowhere and you have to drive 30 miles to get milk, so your average speed is 30 miles per hour, right? But your car during that 1 hour, you might speed up and slow down, right? So your instantaneous speed might increase or decrease. However, it's less useful of a concept than velocity because I know the direction as well. All right. Another way to say it's a little bit better, which I like it better, is basically it's the acceleration in opposite direction of your velocity. It's more precise. Okay, it sounds more confusing, but if I draw a couple of arrows, you'll see what I mean. Right, let me write it down first. So deceleration is basically the same as acceleration, but when the acceleration is opposite to the velocity. Okay, so whenever the acceleration is opposite to the velocity, we call it deceleration. So there's really no reason, if we treat acceleration as a vector, there's no reason to introduce a new word of velocity. All right, so sorry, deceleration. So let me tell you what I mean, right? So if you have an object, if this is the velocity, all right. So let me call the initial velocity. So I'm gonna, because it's gonna reduce, or is gonna, the velocity is gonna increase or decrease, right? Reduction or decrease. Right? Then I need initial and final, all right? Instead of writing VI and VF, I'm gonna write U and V. Okay, V is gonna be final. And this is going to be a very helpful notation. It's a standard notation as well. Of course, this is ambiguous to talk about instantaneous velocity, but usually from context, if there's a U and V, usually that's what it means. This is initial, this is final. All right. So let's say that's your initial velocity, and your acceleration is pointing this way. All right. So what that means is, these are vectors. So even though I'm going to focus on one dimension first. So if let's say this is the length over here is 10 meters per second, and this is 5 meters per second. 1 second later, the velocity is going to be 15, right? Right. So it's going to increase like this. So that's acceleration. Deceleration is if you have U, okay, let me suppress my units, right? 10, but if I have my acceleration backwards, so this is 5 meters per second backwards, then what will happen? Then 1 second later, this 10 meters per second is going to become 5 meters per second, right? So I can write it like this, right? Time and velocity. So if time equals to 0, my velocity is at 10, positive 10. Going the rightwards, assume this is 1D, so I'll just use positive and negative to talk about the direction. and time equals 1, because the acceleration is pointing in the negative direction, that's negative 5 meters per second, then it's going to reduce by 5, right? So let's use a different number to illustrate it. So just to be clearer, right? So let's say it's minus 3 meters per second. So if this is 10 meters per second, the next second it's going to be 3 meters per second less, right? So it's going to be 7 meters per second. So like that, all right? So this scenario, this concept is called deceleration, okay? So now you understand the idea. You can basically do away with the word deceleration and just talk about acceleration in which direction. If the acceleration is opposite, right? If this is the acceleration is opposite from the velocity, and you see it's the same thing as the speed being reduced, okay? Of course, I can't say the velocity being reduced because velocity is a vector. When you say reduced, do you mean reduced in direction or magnitude? Usually it means magnitude, but still a little bit ambiguous. So let's be precise. The magnitude of it gets shorter, all right? So be careful. I'll write it in red. One easy mistake. Sometimes students make the mistake of saying if A is negative, they call it a deceleration. That's not true, all right? So A is less than 0, that's deceleration. Okay, no, okay. I'll tell you why, right? Because first of all, A is a vector. What do you mean by negative? If it's in 2D, then you need to specify the direction more carefully, right? But let's assume you're in 1 dimension. So negative means A is pointing this way. Well, we just so that it looks like a deceleration, but not necessary. What if I'm also, the initial velocity is going this way and the acceleration vector points this way? Does it increase or decrease? Well, it means it makes it longer this way, okay? Let's give an example, right? At time equals 0, let's say you're going at negative 10 meters per second. What that means is this is in 1 dimension. So I can just use positive and negative with respect to my positive x-axis. Let's say positive x is that way, just to define my system. So I can have directions properly discussed. So velocity, if it's negative 10 meters per second, and then I have a acceleration of negative 3 meters per second, then that means the next moment, it's going to subtract 3 meters per second from here, right? So it's going to be minus 13 meters per second after 1 second, right? So just intuitively, because I could as well flip my axis that way and it will all make sense, right? If I'm accelerating, if I'm already going this way, so if I have a car, right, going this way and you accelerate this way, it just means you're going faster towards the left, right? If negative confuses you, just use left and right, and that would be obvious, right? So if you're moving to the left and you accelerate to the left, you'll be moving faster to the left. That's an acceleration. So negative A doesn't mean deceleration, right? It has to be negative. This has to be negative of the velocity. If A is negative of the velocity, then it will be a deceleration. On the contrary, right? So if I'm moving this way, if my car is moving this way, but I'm accelerating this way, right? Then this is a deceleration, right? So I'll draw a car and it'll make sense, right? If I'm moving this way, but I'm stomping on a brake, so you're basically accelerating. You're trying to, or if this is a boat, right? If this is a boat moving on the ocean this way, and then now you reverse the propeller and you try to accelerate the other way, you basically reduce the velocity. So you can use either way, it's the same thing. Basically this causes this. This is a little bit more accurate and I like it better. Yeah, all right. So let me draw out these 4 scenarios. Right, so the first one is an acceleration. The second one is a deceleration. The third one is an acceleration. The fourth one is a deceleration, but we want to be careful, right? This is an acceleration to the right. This is this is why I don't like deceleration. You'll see in a moment. This is acceleration to the left, all right? Is this a deceleration to the right or deceleration to the left? It's an acceleration to the left, right? That's, as you can see, but it's a deceleration to the right or deceleration to the left. let's just not use that word. All right. So as you will see in the textbook and all of the, we'll try not to talk about is deceleration a vector or scalar. Let's not even worry about it. We 99% of the case, we won't use it. The only 1% is in maybe in the problem during in the word as a word problem, you'll see the word deceleration. Immediately translate that to drawing which direction you mean. We'll first deal with one-dimensional motion, and then we'll go to 2 dimensions. So in 1 dimension, immediately draw an arrow and define your axis. So positive x this way. You can do positive x this way. That's completely fine, right? Depending if everything is pointing this way, right? If your car is moving to the left and then you're accelerating and it's asking you how fast the result is, right? You might want to just change your axis going that way. It's positive x. It's completely fine, right? So make sure you define your axis, because you can have a positive number and your friend doing the same exam can have a negative number. But if you draw the x, that's fine. Both is a correct answer. But make sure you draw the x without the definition over here. Then we can't say whether you got it right or wrong, right? So you might lose a point or two like that. So make sure it's important to do that. And yeah, so that's all we have to say about deceleration. So it's a concept. It's essentially, it's a common day word concept. You know what it means now. It's basically just an opposite. A quick comment about 2 dimension. So if my object is going this way, right? If the velocity is going this way and I'm accelerating, this is not a free body diagram. Free body diagram is about forces, but I'm just drawing arrows. Free body diagram usually specifically refers to forces. Anyway, it looks like a free body diagram. So if I'm going this way, I'm accelerating this way. This phenomena as a concept, as a qualitative word or a layman word, we call this a decelerating scenario. If it's like this, we call it accelerating scenario. Now, if it is pointing somewhere sideways, we won't deal with this just yet, all right? This is the topic of next week, all right? So far we'll have everything stick along 1 dimension, and we are ready to make some predictions about falling objects and falling apples and rolling bowling balls and all that, all right? So see you in the next video.